Welcome to Chapter 12. For the first question, we're asked to create a bunch of tables. We'll start by cleaning the state. So if the database already exists, we'll drop it. Then create a new database. In order to create or access tables, we need to be within the context of a database, and that's what we're doing by stepping into the context. We're using the use construct. Now we go ahead and create the parts table. So here are a couple of things. You have a bunch of check constraints to ensure that the data matches certain sanity checks. We use unsigned when possible. For example, the unit price can't be negative, and since we don't want 4 digits of precision, we can use numeric and specify numeric and double are same. We specify the number of digits and the number of decimal points we want. The engine is INNODB. In MySQL 8, it's the default engine. Should your version be different, here's how you set it while creating the table. Go ahead and now populate the data. So all went well. Now we can go ahead and run the select statement to confirm that we do have the records there. There we go. To verify that the primary key constraint is honored, let's go ahead and try to make another insert. None of these will go through because it's a violation of the primary key constraint. The rows will be unaffected now. Now that we know the basics of how to create a table, let's move on to the rest of them. Let's go ahead and create the customer table. Here, I don't know if the balance can be negative, how the business is run. So I've just kept it as numeric of 10,2. I don't want to have 4 digits of precision. If I just use double, the default is 4 digits of precision. You can go ahead and read the rest of it. It's straightforward. The checks again are based either on the string or the length of the domain. So that's about it as far as creating the customer table is concerned. As far as entering data is concerned, here's how we populate the table. Now that we're done with that, let's just select the rows. There we go. We have our 10 rows. Let us now create the orders table. Notice here that we have our first foreign key constraint, and we definitely need the engine to be INNODB for the foreign key constraint to be honored. Now let's go ahead and insert the values. That seems done. Let's go and look at the rows. There we go. A few things. So far you have noticed that the field names would be specified before entering the values. Please do this because as your tables keep evolving, you need to know what you're inserting, and you have to stop relying on the order in which the fields appear in the table. So always do this. And as far as entering date is concerned, the date format could be changed by this underlying settings. So use this function str to date to make things happen. See if the foreign key constraint is respected. The maximum customer ID, the customer number is 622. So if we try to insert into the orders table a record where the customer number is 623, it raises an error saying that the foreign key constraint fails. So we know that we're on the right track now. Moving on to the order details table. Notice the space here. That's why it is enclosed within these backticks, and here's how you create the table again. Let's go ahead and populate the records. There we go, 8 rows inserted. Run a select statement, and this is our output. This brings us to the table creation part of things. Now let's go ahead and dig into Q1. So for each query, they have asked us either to write a query that produces the expected output, or they're asking us to write the query from scratch. So if you look at 1A, they want us to run a query and produce the output. So here's how we do it based on the text file that's provided. Just copy what's on the top and run it on your terminal within the MySQL shell, of course, and you'll observe the output. So that's the first one. Let's move on to 1B. Here's 1B for you. They've already provided the output and they want us to produce query that generates this output. Couple of things to remember. First, you'll have the select keyword followed by the column list, and then from either the table or view, and then you'll have the where condition. Finally, you'll have order by, and since the default sort order is ascending, specify it as descending to make things explicit and get the right answer. Parts 1C, 1D and 1E, they've asked us to run the query and generate the output, and you'll get the same when you run them. The query is on the top, the output is at the bottom. So here they are. Just paste them in the MySQL shell and you'll observe the same output. One tiny detail: when you order by multiple fields, the default sort order as always is ascending. So if you want to sort by descending in one field and ascending in another, wherever you want descending, specify it as DESC and it will be taken care of. When given multiple fields to order by, so it orders the result first by custom number descending, and for those customers who have the numbers as the same value, their names will be sorted in ascending order. That's what this means. 1F, they have asked us to write a query that generates this output. So this is the query. The same story goes for 1G as well. Here we go. They've given the output and they want us to write the query. So you have the query at the top. Let's look at 1H. This part that says customer name greater than D means that we'll start with names like DA and so on. It just should be greater than D. To make the example, to make the statement concrete, instead of D, if we were to make it as T, you'll notice that even Tina Adams would get selected. Here we go. That's what this greater than symbol is supposed to mean. If you look at 1I, the query is to select these columns where the customer name like Adams percentage, which means the name should start with Adams and it can contain anything else. Since no name starts with Adam here, no results will be returned. So that's what 1I is about. 1J, we have two names that have to be returned along with the details: Tina Adams and Lubna Adams. And those are the only two people who have Adams at the end of their name. So we'll use the where constraint, and the constraint is percentage Adams, which means name can have anything before Adams, but it has to end with Adams. That's 1J. 1K has a new expression, the underscore. It stands for one character, but it can be anything. Percentage means that it can be 0 or more characters, and they can be anything. So that's what this particular query does. That's why we have Tina Adams in the result. 1L, the query is given, we're asked to capture the output. Again, the reason for showing this is because I'd like you to look at this a little bit more in detail. It says that there should be two A's in the name. It doesn't matter if they're adjacent. So that's what you should pay attention to here, and these are the records that will be selected. 1M, again we're given the query and asked to capture the output. To jog your memories, it means that A and I, case sensitive, should be present inside the customer name, but it's not necessary that these letters must be adjacent. They can be located anywhere. It's just that A should come before I. That's about it. And here's the output. Before moving on to the second question, I'd like to show you a small trick. Since I've been copying and pasting into the terminal from this particular SQL script, you can just run it in one shot. So here's how you do it. MySQL-u, your username, -p is for accepting the password later, and then you have the lesser than symbol, and you mention the file name from where input should be redirected. Upon entering the password, it runs. To confirm that it did run, here are a bunch of statements, and there you go. Because as part of the script, we dropped the database if it existed. They should have recreated the tables. So there you go. For the second question, the table schema is given, and we're asked to create this table. So now that you know how to load a script or execute a script, so we're done with that. let's move on to the answers. So for 2a, this is the given query. Select these fields where marks 2 is null. We know that null check is done by using is keyword and not equal to. So here's the correction and this is the output. That's about it as far as 2a is concerned. As far as 2b is concerned, they just asked us to execute a query where is not null condition is specified. It's trivial, please do it yourselves. As far as 2c is concerned, the output is given and we're asked to create the query that produces the expected output. This is the one. So the constraints are marks 2 is null, and then you want to order by the student ID, because here we have 12 and then 14. That's about it as far as 2c is concerned. 2d and 2e again ask you to just produce the output of given queries. There is nothing special, so please try them out yourselves. The third question consists of 4 parts, each of which has the output, and they're asking us to provide the query that generates that output. So 3a, b, c, d, each of them contain the query on the top and the output at the bottom. I'll just go over the high points. First up, the in operator reduces the search results to whatever is present inside the brackets. This is not a range but specific values. So where part num in, these two values, those will be the only records that get selected. So this is the output. As far as 3b is concerned, we have a where condition followed by an order by. A reminder that order by sorts in ascending order if no order is provided. For the third question, we want to look at between. Between filters values that are including these two range values as well. So any value that is greater than equal to 108.99 and less than equal to 311.95 will be included in the results. So here you see the output, this and this as well. Order by is specified after the where clause. So here we order by unit price and list it in descending order. As far as the fourth option is concerned, we use a simple between command, between operator. That's about it. Oh, one little detail. If at any point they ask you to write a query using logical operators, you can always replace a between by, so if you consider this particular query, you can replace where unit price between 1995 and 1995, that is, it's going to include just that particular record. So let's consider something else. Yeah, this one. So you can replace unit price greater than equal to 108.99 and unit price less than equal to 311.95. The reason why I didn't explain this was because both the start and end values were the same. It would have caused some confusion for beginners. That's why I picked the other query. Anyways, that brings us to the end of the third question. All you have to do is just paste these queries on your MySQL shell and see the output. Welcome to the fifth question. This is also similar to the third question, except they are specific. They ask you to use logical operators and or not. So here's 5a and the so here again they have given the output and they're asking us to write the query that generates the output. I'll just go over the crucial parts here. So we have not equal to, so that's one logical operator, and then we have and. So usually when they ask you to use a logical operator, and if you are stuck with the between operator, just replace it as mentioned before with the greater than equal to lower limit and less than equal to upper limit, since it's a closed interval. So this is 5a. 5b is again going to use a bunch of logical operators, and not in is not a logical operator technically, but in is used to specify set membership. Not in negates it. So not is your logical operator. Then we have between, which you can again replace with greater than equal to and less than equal to. 5c is not provided here because in the textbook it is a duplicate of 5b. It's just a typing error. So it's technically just 3 questions there, 5a, b and d. As far as d is concerned, between again is used here. Feel free to replace it with greater than equal to and less than equal to. That's about it as far as the fifth question is concerned.